Hello everyone and welcome to this audio podcast. In this audio podcast series, the LabZtorm effect v.3, and around this audio podcast I'd like to the the role of endogenous opioids in Ischaemic preconditioning or IPC in humans. This is an audio podcast in around the sort of mechanisms of remote ischemic preconditioning or RIPC. And this is an audio podcast aligned to the Storm Robotics soliloquy and another Storm Robotics production. So the mechanisms of RIPC, observation has surrounding a sort of autonomic and sensory nerve signaling in RIP phenomena. Various factors, for example, such as angiotensin, adenosine, bradykinin, endogenous opioid peptides or EOPs, reactive oxygen species, ROS, and nitrous oxide and norepinephrine have been implicated as triggers in remote ischemic preconditioning. Angiotensin may have a dual role to its release in stressful situations. Its role was or has been identified by a sort of blockade of A1 receptors using, for example, retrospectively in context of pharmaceutics, losartan, which has in some contexts has prevented cardioprotection or CP. Similarly, catecholamines have or may contribute to protection as part of a systemic stress response. And it appears that our remote ischemic preconditioning suppresses leukocyte activation, and more human investigations have required to interrogate immunological components of RIPC. Mediators including intracellular kinases such as PKC, MAPKs, and potassium adenosine triphosphate or KATP sensitive channels in both sarcolemma SKATP and MKATP nuclear factor kappa beta or NF kappa beta sites have been identified as both triggers and mediators in remote ischemic preconditioning or RIPC. Protein kinase C or PKC, an important serine threonine kinase, has been identified as an important mediator of remote ischemic preconditioning or IPC. The potassium adenosine triphosphate channel or KATP channel has been implicated in RIP as a blockade using non-selective antagonists, for example, and has been evidence as glipinequlamide abrogated protection in animal laboratory models. Nuclear factor kappa beta have also played an important role as redox sensitive transcription factors and regulate the expression of inflammatory mediators, for example, such as lipocortin cyclooxygenase enzymes and nitrous oxide synthase or NOS. Data has suggested, or evidence has suggested, a sort of a pivotal role for nuclear factor kappa beta in a variety of pathophysiological conditions, including renal ischemic-reperfusion injury. The end effectors of remote ischemic preconditioning are also the final factors which reduce the damage by directly affecting the mechanism of ischemic-reperfusion injury. Remote ischemic preconditioning or RIPC also causing metabolic effects which maintains homeostatic, which have been evident and documented to maintain homeostatic mechanisms and prevents accumulation of damaging waste products, in context of physiological pathophysiology. Various proteins such as heat shock proteins or HSPs and free radical scavenging enzymes such as manganese superoxide dismutase have important roles in end effect protection. And so mechanisms in around the protection of aligned to remote ischemic preconditioning or RIPC are still sort of prospectively being investigated. So thank you for tuning in on this particular audio podcast aligned to the LabZtorm Effect v.3. This has been an audio podcast aligned to the mechanisms of remote ischemic preconditioning or RIPC, and an audio podcast aligned to storm blastonic soliloquy, aligned to a storm blastonic soliloquy, and the role, the audio podcast series aligned in around the role of endogenous opioids in ischemic preconditioning or IPC in humans. And once again, it's been another Storm Robotics production. Thank you.